In this video, based on topic 11, the geometry of two-dimensional shapes, we are going to focus on the sides of quadrilaterals. In the previous video, we focused on the angles of the quadrilaterals. The problem with only classifying the angles of quadrilaterals is we cannot, for example, distinguish between a parallelogram and a rhombus, as both the parallelogram and the rhombus have opposite angles equal. So the angles are not enough to classify these. So we also have to look at the side properties. A similar thing happens to the rectangle and the square, because both have 90-degree angles for each of the angles. So angles is not enough to distinguish between these two shapes. So let's delve into the properties of the lines of quadrilaterals. So a parallelogram have opposite sides parallel. So this side is parallel to that side. If you think of the property of parallel, the easiest way to illustrate it is to think of a train. So the wheels of the train needs to be apart the same distance as the track on which the train runs. Otherwise the train will go off that train rail. So even if the rail makes a turn, then the distance needs to be the same. Whether it goes straight or when it makes a turn, the width of the rail always have to be the same. So the same with the other side of the parallelogram. It also have to be parallel. So parallelogram in fact have both pairs of opposite sides parallel to each other. The rhombus have the same effect in the sense that both pairs of sides are parallel to each other. So this side is parallel to that side, we indicate it by the one arrow. This side is parallel to this side, we indicate it by the two arrows. So what's now different with the rhombus is in fact all four sides are also equal. When we study the rectangle, we know also that the opposite sides are parallel. This is indicated by the one arrow. This side is parallel to that side. We actually should have had two arrows because we already used the one arrow here. But then we also have our 90-degree angles, as we already know from the previous video. Now, when it comes to sides, the opposite sides have the same length. So this side has the same length as the opposite bottom side. The left-hand side has the same length as the right-hand side. We indicate it by the two lines. The top and the bottom having the same length, we indicate by the one line. Now if we look at the square, similar then to the rectangle, the opposite sides are parallel. So the top and the bottom one are parallel. the left side and the right side is parallel as indicated by the one arrow. But now what we see is all four sides are the same length. So the distinguishing factor between the square and the rectangle is for square all four sides are the same length as indicated by the one line, whereas for a rectangle all four sides are not the same length. Only the opposite sides, so the top and bottom side is the same length, and then on the other hand the left and the right hand side is the same length but a different length than the top and the bottom side. So next we focus on our guide. So we have two guides here. The property of the guide is that adjacent sides are equal. So this one line indicates that these two sides are equal. The two lines indicate that these two sides are equal. Similarly here, this side and this side, these adjacent sides are equal. And then this side here and this side here, as indicated by the two lines, are also equal. So adjacent means next to. So this side and this side is adjacent as they move away from a common angle. But now the thing is, you need to get the correct pairs of adjacent sides, because we know we have for guides what we call the property of symmetry. So here's our symmetric line, so therefore this side and this side are mirror images. This side and this side are mirror images. Similarly, here we have our line of symmetry. So that this side and this side are mirror images, and this side and this side are mirror images. Then finally we get to our trapeziums. So we have two trapeziums here. What we know about the trapezium is that there is one pair of parallel sides. So this side and this side is not parallel. This side and this side is not parallel. There are no arrows. Only the top side and this bottom side is parallel as indicated by the one arrow. For this one as well, this side and this side is parallel as indicated by the one angle. The other two sides are not parallel. So what distinguishes a trapezium from a parallelogram is that only one pair of sides are parallel for the trapezium, whereas two pairs are parallel for the parallelogram. Also for the parallelogram, the sides will actually have the same length, whereas for the trapezium the one side is much longer than the other side. So let's use the line or side properties rather to classify some quadrilaterals. Exercise 11.4 requires that we classify these quadrilaterals based on the marking shown on each sketch. The sketches are not drawn to scale, they are never drawn to scales. You need to know the symbols, like the arrows means parallel, the stripes means same lengths. So give reasons for your answers. Yeah, here the reasons are the actual crucial factor. Just saying that something is a kite or a rectangle or rhombus doesn't really count. You have to know why it is a rhombus or rectangle or square or whatever. Okay, so let's first look at number 3. So what I can see is we have an arrow and an arrow, so we have these pairs of side parallel. We have two arrows here and two arrows here, so the top and the bottom sides are parallel, so we have two pairs of opposite sides parallel. So possibilities that we actually have here is the parallelogram. Okay, PALM is the acceptable abbreviation for parallelogram. And the other option is a rectangle. What else? Squares. Rhombus. Those all have two pairs of opposite sides parallel. But now what we see is we have sides with the same length, namely JK and JM as indicated by the one line. Now parallelogram, we know the adjacent sides are not equal, not necessarily equal. So it can't be a parallelogram. We will have to take that one out of the equation. A square is a possibility because all four sides of a square are the same length. A rectangle, no, because the opposite sides are the same size, not all four, so it cannot be a rectangle. A rhombus, yes, a rhombus have all four sides equal. So now we have two possibilities, either a square or a rhombus. But now we know squares have 90-degree angles. Rhombus don't necessarily have. Do we see any 90-degree angle here? No. So therefore it cannot be a square. It therefore has to be a rhombus. So our reason would be two pairs of parallel sides, all sides equal, and no 90-degree angles. Yes, so two pairs of parallel sides, all sides equal, and no 90-degree angles. Instead of saying all sides equal, you could also have said adjacent sides equal. Because they actually only gave two adjacent ones. But if adjacent sides are equal by logic, it will mean that all four sides are in fact equal for any shape other than the kite. So let's have a look at number 5. So for number 5, we have the blue lines that are parallel as indicated by the one arrow. They are also equal as indicated by the one stripe or line. So now let's see what are possibilities here. We know it can't be a trapezium because for a trapezium the opposite parallel sides cannot be equal. The one is much longer than the other one. So a trapezium is out of the question. So what are our possibilities? Okay, when it comes to sides that are equal, we have basically the parallelogram, We have the square, we have the rectangle and the rhombus. In fact, the same scenarios we had for number 3. Okay, so now for a square, we know all 4 sides are equal. So we need to have adjacent sides equal, which we don't have in this case. So it cannot be a square. That one we can safely eliminate. The same thing with the rhombus. We'll have to eliminate that, because the rhombus also have adjacent sides, since all 4 sides needs to be equal. So we are left with the parallelogram and the rectangle. But what do we know about the rectangle? It has 90-degree angles. We don't see necessarily any 90-degree angles. Otherwise, it would have been indicated with a marking like this, which it's not. So it can't be a rectangle, so the only thing that remains is a parallelogram. So we can say that STUV is a parallelogram and the reason is that we have opposite sides parallel. Okay, this is the symbol actually for parallel that is generally accepted. So opposite sides parallel, opposite sides equal, and no 90-degree angles. Number 6. Let's see, we have equal sides all along. What are our possibilities? Only the rectangle. Nope, not the rectangle. Only the square. And the rhombus. Only those two have equal sides everywhere. So now, do you see any 90-degree markings? No, I don't see. So we know the square has 90 degrees angles from the previous video. It can't therefore be the square. So we are left with the rhombus. So therefore VXYZ is a rhombus. The reason being all 4 sides equal and no 90-degree angles.